So blockchain scalability issues and emerging solution, how we can really cater the scalability issues of blockchain and how we can cater it. So first of all, I'll jump towards you all and would like to ask, how do you think blockchain is scaling, and what are the issues which it is facing? Like whatever, if you know, how small ever, doesn't matter. Please tell me, how do you see blockchain scaling up, and what's the uh, questions it is coming up, and why it is not scaling, or how is it non so easy scalable? So drop your questions, drop your thoughts. I wanted to know, and let's start off. I don't see a lot of people gave me the blockchain scalability issue, but uh, let me go ahead and put some light on how blockchain has its redemptions. First, blockchain is pretty slow. Blockchain has its benefits, no doubt, but blockchain has its complication as well. First, blockchain is very slow. How it is slow? Uh, it takes a lot of time to create a number of blocks and number of transactions to be done within that block. Those numbers are very much limited, and those create a concussion of blockchain scalability issues, which are very high up there. But let me add much more towards it by giving you an idea that blockchain has been revolutionary in creating trustless distribution system for multiple purposes. However, as the adoption and use of blockchain network continue to grow, scalability has emerged a significant issue. Like I believe there are some key issues which we can start off discussion. Limited throughput is the uh, key point which I would add, which is one of the very first relevant point, that blockchain has a lot of limitations with limited throughput out there. So traditional blockchains like Bitcoin and Ethereum can only process a limited number of transactions per second. For an example, giving you the Bitcoin as a best example, Bitcoin network can handle about 7 transactions per second. So means globally more than a billion people is using Bitcoin, but only 7 transactions can be really done in a second. So that's a very slow number. For a reference, whosoever is living in India, UPI has a ratio of around 2,500 transactions to 3,000 transactions. Now they are claiming 4,500 as well. but the original numbers are somewhere between 2500 to 3000 transaction per second can be done by UPI. So whenever you are transactioning through UPI, you must have seen there is a delay which takes place. Like transaction is taking place for few seconds. That is what high finality is taking place. Your transaction is taking place. The transaction is going through the network of P2P network, peer-to-peer network, as UPI functions in a same P2P manner, like blockchain. So how many of you have noticed that if you are doing a transaction through Paytm, PhonePe, it takes few seconds, then it shows the transaction is done. Sometimes, Paytm used to say that, okay, transaction was the quickest in Paytm. So how do you see? You guys have seen those things taking place? Yes, no, like you guys usually do a lot of transactions. Whosoever is in India has done a lot of transactions through UPI. They must have seen a delay of 2-3 seconds, which generally take place when they are doing to do a transaction on Paytm or anywhere, and it takes few seconds. The loader moves around, and you wait for transaction to see happen. Transaction actually is done in few macroseconds, but it takes a lot of network management and other things to take place behind the scene to show you the transaction which is there. So if you guys have seen Paytm, etc., has a delay, that is because again, transaction limitations are there. So I told you about Bitcoin that it can process around 7 transactions per second, while Ethereum can handle around 30 transactions per second. That's the max they can go. And if there is a lot of rush to do it, gas prices go high, means you have to pay higher number of token to get your transactions through, because that's how it is done, because system needs more gas, or the gas is gone up, so it will slowly take the consumption rate. So likewise, how petrol rate functions, the similar functioning of blockchain based tokens are there, like petrol. As petrol price goes up, you pay more to get the petrol. Similarly, gas is kind of token only, but which is used in blockchain for powering up the transaction. So that's a very you know high issue which is there. And if you guys have done transactions through Mastercard, Visa, or POS machine, you must have seen there is a lot of delay in transaction processing, like centralized payment system. Uh, there is also a delay, but if you know, they do around thousands of transactions per second. So they do 30,000 transactions globally per second. So more than 5 billion people using the Visa or Mastercard network can do transactions in seconds. Still, you have to wait because your transaction is taking place. So systems have a high throughput issue, which is very common, and limited through output is a very common issue, which blockchain also faces. Then block size and frequency. I'm typing the topics as well here, so you guys can get an idea that how these can affect. Let me figure out some pictures for you. Okay. Okay, let me. Hmm, let me share the screen and get you updated on the block sizes. So I guess my screen is visible. So you can see the average block size, how it is decided. block size and frequency, how is it is decided. So this is a average block size in a year, which is there, which varies from zero point zero 0.08 bytes to around 2 MB. 1 MB, 1.2 MB, 2 MBs. There are multiple various sizes which fluctuates with the block size, and this is the differential which is there. So this is a total block size of Bitcoin. Ethereum block size can vary according to Ethereum transactions as well. So let me check the blocks. You can see, if you can see on your screen, these are the blockchain transaction taking place. Here, a new block will be formed with the number of transaction. And if you see, the blocks are half filled and half not filled. This shows the number of transactions, etc., within a block, how much they have consumed. Is it visible? So, every time a new block will be mined up, a block can be seen added up here. And if you all see here, all blocks are serial numbered 175407726, and there is a duration at which a block can be minted. It can be a 30-second, it can be a 1 minute process. So it varies from size to size, and you can see this block is half filled, this block is full filled. You can see this block details would be there. You can see there is a very low number of transactions out there. But if you see the full block which is there, taking an example of this block in front of you, you see there is more number of transactions which are there in this block. So these things, block sizes and block transactions vary on case to case. And once the blockchain is formed, these depends on the cases and what number of blocks to be formed, what block data. See, you can see this block is 100% full. So let's check what's the size of block is. So this total block consumes around more than 1,000, around $150,000 of value, which is around what, more than a crore rupees were sent in a block with the average transaction of at least one. The transactions took place within this block has transaction hashes of $1,000, and total reward which was given to for this block was $37 for the miners, or for the stakers, because it's a POS concept. Stakers, an additional reward was paid for 103 transactions which were included in this block. So it's one of the high value block which has been minted and which has high value transactions within it. And there are number of difficulty levels are there. That watch difficulties level, total difficulty level is there, how much gas in form of Ethereum consumed, how much result it drew. So all these things are there in the every block which is mined out. And when we are seeing this, we saw this block 17504,730 which was full. But you can see, when I was talking about, these numbers of blocks were already minted. All these contain some set of transactions. So that's how it goes within blockchain space, that each block flows and there is a transaction within it. But at that time, it is very good and healthy for blockchain to know it. But there is a very high chance that it is also one of the reason which is causing a limitation for the blockchain. So the size of each block and the frequency at which new blocks are added to the blockchain also affects the scalability. For an example, Bitcoin's 1 MB block size limits 10-minute block creation time. So it contributes to low throughput directly. So increasing the block size can lead to faster transaction, but might get results in other issues of centralization. So as network decentralizes, the network becomes slow. That's what the very simple limit is, because as that block size grows, validators limit to validate multiple systems will also get affected. So these are early two signs which is there. There are 3, 4, 5, 6 more key issues which are there. But if you have any question, drop in. Then we will move towards the third aspect of blockchain problem, that is network latency. Mm, how to improve scalability can be given. I'll talk about that, how you can really scale blockchain in second part of this lecture itself. But would like to know if anyone has more question till on the block size limits, etc. If you need how it is created, there is a whole coding process and there is a whole smart contract deployment process which has to go through. That's a bit technical, but as of now, my lecture has been limited to just keeping it to non-tech aspect as well only. So I'm not going in that tech deepness, but would love to connect on that as well. But any other questions, I will update the scalability part. But network latency ke pehle we move to other aspects. Anyone has any other question which they feel they should ask or tell or anything? Okay, I don't think so. If there is a question, if you're typing your question or anything like that, please do raise your hand instantly, so I get an idea that you guys are looking to ask the question. But if you don't raise your hands, it's difficult for me to tell that you are looking to ask a question. Okay, so moving ahead, one of the key factors for slowing up the blockchain after limited through output and block size and frequency issues. The next part is the network latency, which plays a very key role in slowing up the blockchain. Or you could say network latency is faced everywhere, in calling up, in network connection to Zoom meetings, to anywhere. Network latency is everywhere, and it affects system largely, and it has a lot of impacts as well on how system can be there. Can we use it in expression proof? Yeah. Okay. Expression. You're asking Sumit ji, expression proof आपको चाहिए, description proof. It's a you know बिल्कुल हेल्थ सिस्टम वगैरह पे यूज कर सकते हैं, फुल प्रिवेसी ऑप्शंस आर देयर, But what you're asking, I'm talking about is a detailed options on how it is, scalable, etc. Block sizes. You're asking something which is privacy and tamper-proof design systems, which is always there in blockchain. And blockchain on self guarantee, but it doesn't guarantee privacy because all the transactions you saw are in public. You can know which wallet did that, what set of transactions. So for privacy, you can go with the encrypted set of blockchains or a permission blockchain, which can add privacy layers as well. Going ahead with the latency options, like how latency works within blockchain. So, you know, the time it takes for a transaction to be propagated across all nodes in the network can also be affecting the scalability. So in decentralization networks, transaction must be validated by multiple nodes or multiple validators, which can be time consuming, especially if the network is large. Like you saw Ethereum is taking so much of time to validate it, rewarded so much of fees, a lot of numbers are there. So network becomes slow. So network latency is a very high problem which is there. So for an example, anyone is aware which is the world's fastest stock exchange, which has a user interaction. I'm not talking about supercomputers, but there are systems which has a lot of human interaction and is the fastest. That is the stock exchange. They are the globally fastest computing systems. But anyone aware which is the fastest system out there? Yes, no, yes, no, anything. I want to hear. Everyone, please. A single no. Someone answered it very well. See, network latency is very less in Bombay. Exactly. Bombay Stock Exchange is the globally the fastest exchange there. Uh, it is said by Virendra Kumar ji first, and then Mamta Anand added. So, uh, what's the speed? Can you guess what's the speed with BSE network trades? It's very remarkable, actually. So, Bombay Stock Exchange manages around 25 transaction per macro second. So, oh, 6 microsecond. Oh, I was wrong. It's 6 microsecond. That's one more establishment. I had older data. I guess BSE has updated themselves. So these Bombay Stock Exchange process, 25 transactions around as 6 microseconds, as Mamta Anandji mentioned. So they are the fastest network with the lowest latency out there globally. So you can imagine how speed and how higher clocking options gives in a place where security or cryptocurrency or market is traded. You need a very high throughput options and high throughput numbers, which can really give you a easy way of scaling and easy way of growing. That's what we believe blockchain should always have. And as you can see on the screen, how it functions. A transaction is requested, a transaction is then broadcasted to P2P networks connected with computers or nodes or validators. Here you can refer nodes as a validators. The network validates, yani ki jo bhi, whosoever people are in the network, in the P2P network, will validate the transaction using algorithm. After verification, the transaction is combined with others to create a block of data for the ledger. You see the block you saw, the biggest full block, it had it had more than 1 crore rupees, 1 crore rupee value plus transaction details on it. So you can guess how much it did. An average transaction size was $1,000. So it was more than $150,000 transaction. So you can imagine 150 plus transactions was done within that network, which was verified and add embedded in that block, which we saw few minutes before. And so that's how those block combines, and create a data of ledger, and then the new block is added to the blockchain in a way to that they cannot be changed. So one block is obviously previously connected to other block. As you have seen, again I'll show the blocks, how blocks are looking, how blocks would look. So uh, as you see, I am again sharing the Ethereum transactions taking place on the screen. Each block is connected with each other, and as we are talking, a block is getting collecting the transaction, it's minting up, and it's validating all the transaction which is done, and it is giving you the results. See, it does a lot of things within a few milliseconds, microseconds, but it is still slow. You cannot consider that a very fast network, and every block is connected with previous other blocks, so it cannot be ever changed. That's how blockchain's basic functioning and the rule of law is of blockchain. Then coming towards the storage requirements of a blockchain, that's the next part. But again, giving an option, if you guys have any question, uh, happy to answer meanwhile, so that we can quickly jump towards how the storage of blockchain is there, and how the blockchain storage is causing an issue. I'm awaiting questions. I give usually 1 to 2 minutes so that I can get a question out there if you have any. Mm, okay, no questions. Acha, there is a question, sir. In a new block, are the same cases or different? Every block has a different case, ma'am. Every block has a unique new case, a unique new transaction hash, a new transaction ID. Your transaction, or you are doing something on blockchain at two different time, can have been in two different blocks as well. So there's a very high possibility of that. Okay, so I guess we have these number of questions. Let's limit towards what is blockchain's major concern, that is blockchain data storage. How blockchain data storage is a big problem. If you see on your screen, acha, there is more questions. How transactions are being packed in a block. So a block, see, every block has a fixed time limit in which block is minted, Shyam Deshmukh ji. Every block has a fixed time that every 2 seconds a block will be minted, or a 3 seconds block will be minted. And in those 2 to 3 seconds, uh, the block size is fixed, that okay, this will be having a 2 MB say, if there is a data above 2 MB, the block will not take that. So the timing and the data, it matches. So if you are doing a 50 transaction within a, single second of that block minting time, those transactions will be transferred in those block. And you did 5 seconds later another transaction, it would be given into another block. It will be packed in another block. So there is a limitation fixation which is there, that okay, the number of transactions taking in that block timing as well as the size of that transactions, These all decide the factors in which the blocks are packed. Yeah, there is a lot of internal fragmentation which can be really seen. If you want to jump in before going ahead with the blockchain storage, let me share you how it looks. See, I'm clicking over a single block which was mined on Ethereum just few seconds ago. There is a lot of internal fragmentation. You see, it mentions a total of 34 Ethereum, costing around $64,000, were sent in a block with an average transaction being $600 a transaction, and earned around these numbers, rewarded these numbers. It has a hash, this number, it has a parent hash, this number, it has a SHA3 uncle, which is a security hash, then a state root, a Merkle hash, then depth one, capacity of this person 2% was totally utilized, distance 54 seconds ago this block was minted, the rewards difficulty of solving this was there, this number of gas percentage was used, gas limit, and then we go ahead with mined at what time, who was the miner of this block can also be seen, means who is the validator. Transactions this block contains was 96 transactions. Internal transactions it reported was 152 transactions sent and received at these value, internal values, average values, median values, block value, minted value, fee reward value. And if you want to see the transactions within this block, these are the transactions with the values that okay, these number are the transactions which are limited. So there are 7-10 pages to just go for the transactions. So you see there is a lot of internal fragmentation can be seen. Blockchain might sound a bit complicated, but it's a very difficult management, and that is why it's a very rewarding application to really be on and build on. Because as you see, as things are growing, blockchain would be the regular go-to thing, or could you say that another layer of thing which would be there, like you are creating an app, there would be addition of blockchain, there would be an addition of AI. Blockchain would be as similarly as adapted as it was, it is it would be in upcoming 2-3 years, your banks will have blockchain and you will not be aware of even that your bank is actually using a blockchain based network or systems for a highly definitive use cases and go throughs. So those things are there, and it would be changing the world out there. So a lot of internal transaction, internal work will take place. It's just as we grow, as we keep a check, it would be easier to understand as we learn more. So going towards what is blockchain storage problem really. uh, So as more transactions are added to the blockchain, the size of blockchain increases. And this means the node have to, or the validator have to store more data, which can be prohibitive for individual and small organizations. So if a single person is running a validator node for Ethereum, Ethereum will grow. Ethereum is growing. You just saw 2 MB, 3 MB data in front of you. How much that was in a single block. Can you imagine? There are every 2 seconds there is a block is being minted, and it has all the details. It has been finality out there. So the chain is growing every day. It's growing, and it's growing in a very higher stage, and that would some way or other way cause a lot of problem in the blockchain scalability. So data management, or Filecoin is a company which provides data storage for blockchain. In There are multiple companies which are adding every day, which provide data storage for blockchain, and which has a very high data limit. So that is why in blockchain you cannot easily run a node or become a validator of any network, because that requires a lot of infrastructure behind you to run those things and to become a part of it. It's highly rewarding, but again, it requires a high level of capital and infrastructure to be first given before to start off. What data to be stored? These data, every data is getting stored. Whatever you see in the transaction taking place, the transaction hash, the transaction details, which wallet did a transaction of what amount, these everything gets stored in a block. Every block gets stored. That is why it's a P2P chain, and it is not erasable. These data sets are then compressed and keep in the data files for always. It is always available. That's how blockchain has been. It's a highly growing system and highly conserved, and but it's scaling very fast. And this data storage is a very high problem in blockchain, which is there, because as you keep growing, the blockchain grows. And as of now, Ethereum, uh, for running a node in Ethereum, you need around 5 to 10 terabyte of space. That level has been reached by Ethereum. Those number of transactions has been reached by Ethereum, though it's a very small number for companies like Facebook, Google, and big organizations who are running storages in tons of trillions of terabytes. But for blockchain, 5-7 terabytes of data is also very big. So one of the largest networks as of now is Ethereum, which has around somewhere requirement of data storage between 5 TB to 10 TB. So it is a problem which is growing, because you need to manage those data and those numbers of applications out there. But we have to literally move towards energy and data conservation, and those steps are being taken. But as of now, those are the challenges which is there. uh, Now, coming to the point, data storages are in two formats. It depends what type of data you store and how you store. So in previous session, someone asked me which wallet to keep in. I mentioned hot wallet or cold wallet. Means hot wallet is a data whose data is on chain, means you can see it live. You can see what transactions are taking place. And then there is a off chain data, where you take the things offline, where your data is transacted offline to some device or some storage, and it is stored there for a longer period of time. That is also termed as cold wallets, which is where data is there, and cold nodes, where data is stored for a longer period of time. So off-chain, on-chain data are always there. Like blockchain data can be in off-chain, in on-chain, depending on. It is like you had a UPI, you went to ATM, uh, you had some numbers in your account, like you had 5,000 rupees in your account. You withdrew 2,000 rupees, and that 2,000 rupees or $2,000, whatever you want to understand, is now with a cash with you. It is not traceable where you are spending until unless it comes to the network again. So off chain data is like taking out a cash from blockchain. It's as similar as that. So those storage are independent, and that's not directly connected to the network. But once you connect to the network, it fetches all the data or the all the transaction details. With cash, you cannot say where did I send the cash or where who I gave the cash. But with blockchain, off chain also, everything is recorded in a ledger. Once connected again, it will record back that okay, these numbers of data were connected to these set of people. So transaction has that transparency as well as traceability even off chain. So there is no escaping out of it. So these are few challenges. And then there is a next challenge which is very high, that is market fees or the transaction cost. If you have seen as of now, when I was showing the things, you saw each block has some set of numbers with them, which says okay that this number of this thousand number value $1,000 of value transaction took place, etc. These are the gas fees collected from each transaction which network earns. And as I have previously given an example, gas is like petrol, which is required. Again, you can use your token to get it, or your token is a gas also, or your cryptocurrencies act as a gas in the blockchain as well. So the price goes up as the demand grows, supply is very limited. So blockchain has a limited supply. The transaction and the cryptocurrency tokens are very much limited. They are not growing every day. So the blockchain tokens are fixed, and but the gas is going up, means more people are engaging. The supply is not there, but the demand is growing. So the gas price shoots up in the blockchain as well, and that's a bigger problem when you are doing so multiple at multiple times. Some big NFT airdrops comes in, means some big organization is dropping an NFT or launching an NFT. At that moment, a lot of people plug into the same network. At that same time, they want to do a get that NFT. Take an example for IRCTC reservation. So if you do a IRCTC or a railway reservation at Tatkal period, there is a fixed timing that at Tatkal window opens for reserving Tatkal tickets. Do you see it's how hard it is to get the Tatkal ticket, because network latency is high, plus there is a high demand and the supply is limited, and still you don't get a Tatkal ticket. How many of you face that? I guess most of you have been faced, whosoever is living in India have faced a IRCTC Tatkal ticketing issue, that at Tatkal timing you don't get ticket usually, because again network is busy. So the demand shoots up, the tickets are limited. So very few people gets that. So the similar goes with blockchain. At times the network shoots up, the gas price shoots up, and at that moment transaction is way high, way costly than you can imagine. So it's like that. uh, that's what it has been. And if I guess you guys have understood, I wanted to know if you guys have any question till now on the gas part, so I can share. I can give you a brief uh, statement on these as well. Like, as a network become congested, transaction can skyrocket. This is basically users who are willing to pay higher fees to ensure their transaction are processed quickly. This can make using blockchain expensive and impartial for small transactions, not for large transaction. For small transactions, it can make it difficult. So uh, any doubts till now? These are few limitations which is there within the blockchain. uh, 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 if we try to implement image search using blockchain, then does entire image should be stored in each block? If yes, then the storage depends on the number of images, or anything can be and can be done. I don't get you. Why your image has to be stored on blockchain? It can be converted into NFT and can be a singly shared as a single file. Uh, why to keep it in a very distributed image? And image search has a very different algorithm. It would be very much similar like NFT engine, NFT search. Uh, yes, it can be stored in different blocks. Depends. Multiple blocks can be the owner of that image, or multiple blocks can be the custodian of that image. But privacy preserving image search. Yes, IPFS. I was coming to that. Okay. See, you are saying something which is very different, Mr. Kunj Bihari ji. That is block determination and you know इसको blockchain पे how we will do it? It's a personal identification information provided to handle service providers. And okay, I got it. But mm, privacy preserving image search can be there, but it could. I would suggest using a.
Hello.
Yeah, yeah.
Yes,
Please,
yes.
Vatsali.
Yeah, actually, sir, privacy preserving image search we can use in healthcare system where images are so sensitive, so that cannot be shared with everybody. So in that situation, we can use the blockchain to store the images, okay, privately, so that these images cannot be manipulated or privacy should remain intact. So I have read several research papers, but there was a confusion that if we are going to store entire images on each block, then storage will be the problem. So any
Yeah.
idea?
Storage is a problem, and I would suggest don't store image on blockchain. And if you
Yeah,
are storing
actually,
a
yeah. Actually, we will be not storing the complete image, so we will be storing some features. So that is there. Okay, so let's say in that case also 10,000s are there. So for 10,000 images, we will be having like one image vector. Okay, so like hash values of 10,000, because that will be again a matrix of 10,000 rows.
but
So
that's doable. No, 10,000 image searches are doable. When
okay.
10,000 hash searches are doable, then image search is a very difficult game. And why do you need to keep it in a public blockchain? Create a private
Yes, sir.
permission.
We will do that private
Or
blockchain using
getting
like
there is a
uh,
scalability option called app chains also, or roll-ups are getting every day rolled out. So you can store on roll-up. They are very cheaper, and storage consumption is also there. So blockchain has four components, and data availability layer and settlement layer are two different layers. So settling a data is one thing, and data availability on the other part is different thing. That makes blockchain costly. So if you keep the data on this layer, settlement layer, date etc. on settlement layer, and image files on data availability layer, it would be cheaper and it would be more easy to conserve. Why divide it? Go for modular blockchain. Modularity is a very higher option which you can opt in these cases. See, everywhere you cannot go and store on Ethereum or Solana or L1, L2s. You can go for L3 or L4 models. Modularity is out there. Celestia is out there. Even air chains. We are coming up with our roll-up services, as services, in which blockchain can be much cheaper. You don't have to go with the Ethereum level cost and etc. So there are scalable options for use cases. It varies again, but as of now, I was sharing about the fundamentals. So I kept myself to fundamental much more. Again, yeah. So Srushti Diwareji has written IPFS. So you wanted to know about IPFS. It is something very interesting, and the organization which made IPFS made further Filecoin, and that's a very interesting use case because IPFS is a type of storage form which blockchain uses to store on the network. And pretty much all the details previously before Filecoin or any other data availability layer was in common. IPFS is the common method which is used. So if anyone wants to know what is IPFS, IPFS is an interplanetary file system, and it is a protocol network designed to create peer-to-peer method of storing and sharing data in a distributed file system. And it's an open source project by Protocol Labs. And giving you an idea, IPFS distributes the data information across a wide area network like internet, and relying on centralized server and cloud servers to control those. Instead of relying on those, IPFS relies on distributed network where all user can store some conservative contributed data storage and distribution. So IPFS helps content addressing. It can be it's stored on someone else computer, encrypted, with no location, etc. But whenever you need, you can cryptographically pull up, because it has a unique cryptographic hash, so you can pull up whenever you want, and it's in a P2P network, and it's a decentralized network. So it's a very high data storing thought out there, IPFS. It was a protocol which was created by Protocol Labs earlier, and it's a very awesome thing. Now they evolved it to Filecoin. Filecoin is again another update of IPFS, and it's more easier to use and easy to store. And it's mostly, Filecoin has a token, so file utilization is there. IPFS was a pure protocol, to be honest, and it was open source and created just to serve the purpose. So IPFS is one of the data storing methods in blockchain, which can be later on used. On chain and off chain, which one is better? Mamtaji, depends on what type of usage you want to do with your application. That would cause the on chain and off chain, which is better. You don't need to do off chain transaction. It is very much limited to DeFi, or where networks are shifted. Off chain transactions are not very common with general purpose. It has a specific purpose, and it's very much limited to those set of things only, where off chain is limited to the regular purpose. And then what we have, okay. Any more questions, or we can move ahead with the how to scale it, how blockchain can be scaled? Mm, I don't think so. Questions are there. Okay, so off chain, on chain. Let me share up transactions. So, okay, let me share it with you all. Blockchain can be really scaled using few solutions, that is layer 2 solution, side chains, plasma, interoperability, optimistic, and zk rollups. As I have said, rollup is one of the trending things which is going on in blockchain as of now, and it is viewed as the scalability goal which would be offered. But let me start with the layer 2 solutions. So as of now, Mamta ji, last time you asked a question on off-chain, on-chain, right? You can see here, there is a on-chain data and a off-chain example as well, how it can be seen, off-chain, on-chain. So, yeah. So I guess my screen is visible. So blockchain scaling, generally off-chain, on-chain have multiple scaling options, but going ahead with the thought where blockchain is really scalable comes to a triangle of blockchain scaling, which is scalability, security, and decentralization. All have to be kept in check, and then scaling is determined how blockchain can really scale. So let me bring in this before coming up with the details of what is L2. uh, Ethereum and these Bitcoin, Solana, these are L1 chains, layer 1 blockchains, which is called L1s. Then there are L2 solutions, which is built or built using L1, or they have somewhere connected to L1, and they are called L2 solutions. So blockchain scaling can be really done through L2 solutions. So L2 solutions are the protocols built on top of the blockchains or the L1s to increase its high throughput. Means multiple transactions. For an example, Bitcoin Lightning Network and Ethereum Radian Network. There are two different blockchains in the name of Bitcoin and Ethereum Lightning Network and Ethereum Radian Network that allows transaction to be made off chain and only settling the final balance on the main blockchain. So, giving you example, you can see on the screen there is transaction taking place in a L2. The 2 you see is a L2 or a side blockchain. It is also a blockchain. But the data, whatever transaction happens here, he settles it in the main chain and it settles on the main chain, like providing proof of locked assets on the side chain and providing proof of locked assets on main chain. So they share the data, whatever tokens are moving here and there, what are the transactions moving here and there, all the transactions are generally shared in a side chain, and which is very scalable method, L2's method. Polygon started as a L2 method out of India, and it's one of the most looked at L2 methods globally. Then there is a roll-up method which comes next to it. Roll-up method, these are the layer 2 solution that bundle many transaction into single one, greatly reducing the data storage around the solution to uh, could be let me give you a basic idea how roll up what is roll up. So imagine you have a toy box full of your favorite toys, or your kids have. Every day you play with them, move them around, and sometimes bring a new one in or take somewhat out. But every night your mother or you wants to know exactly what you did with your toys. So she wants to know which toys you played with, where you moved them, and if any toy were added or taken away. So now, if you had to tell her that every single toy one by one, it would take really long time. Uh, that's how it is. So you played with so many toys, moved all of them, and maybe even added or took them away. Some you shared with your brother, some you shared with your sister, or some you left it. So uh, this is where roll up comes in. Instead of telling your mom about every single toy, that okay, I used this toy at this place, one by one you write down everything you did in a little book. You write down which toy you played with, where you moved them, and if any toy were added or shared with your brother or sister. Then instead of telling your mom about each toy, you give her the book. She can also look the book and see everything you did with your toys in one place. It is much faster and easier for both of you, for kid and the mom. So blockchain rollup is kind of like that little book. When people use blockchain like Ethereum or Bitcoin, they do a lot of transactions like playing with toys. Each transaction can be checked and added to blockchain, like telling your mom about each toy, what you did with that in that day. But this can take up a lot of time and energy. So instead, many transactions are bundled together in the rollup. Like this rollup is then added to the blockchain. This way, it's much faster and easier for block everyone. So that's how it is within the roll up space. So it's like giving you one more example. There is a pea. If you have eaten peas, mutter, whatever you say, peas can have 5 6 pea beans in it. So each bean has around 10 blocks within it. So once you do a lot of transactions, uh, and you add that in one bean, and then you give whole 5 6 bean bundled with a single P. So that's how roll up is. That's how it is scalable. That's how it is cheaper. That's how it's easier. So that's a very, I know, difficult concept at first to understand. That is why I gave a toy example also. I feel toy is one of the thing which can be easily understandable to a lot of folks out here. But these are few early stage, system which is there, then which will help blockchain really scale. So that's a brief idea. Let's move to the questions, and then we will sum up. Is there? Uh, See, block failures can be there. Transaction failures can be there, but book cannot be corrupted. If you want to corrupt the book, the whole chain will get corrupted. It's not doable. It is not doable. The whole blockchain would become a waste if there is one issue or one error. So there is no chance of corruption. That is why blockchain a very highly secure, highly traced environment. Uh, Please ask questions. Whatever questions you guys have, please. See, if you're feeling you cannot ask questions here, you can connect over my LinkedIn. I'm sharing it to you all. I would be reverting, but please give a reference uh, that where uh, where I can understand where we are connected. How is gas fees reduced in Polygon? Polygon is a L2 solution. That is why it is the gas fees is very much reduced with Polygon. Polygon is an L2 solution. That is why the gas fees is low in Polygon. As I mentioned, L2. Let me share again the L2 details. If you want to see L2, how L2 functions, layer 2 module. Yeah. So here go my LinkedIn out there. I have shared it. So if you guys have any question, you can pull in up there. Meanwhile, if you guys have any question, please ask, or I'll wrap up the session. Uh, can we go with the use case and then question? What set of use case you have? Tell me. Let's look at it. Tell me about the use cases which are there in your thoughts. I'll go ahead with that. Then deploy. Then Sushil Kumar Azadji writes, can you tell something about your organization? I'm from Airchains, airchains.io. We are a middleware platform, means our tools can be utilized to deploy any sort of blockchain quickly and easily. Uh, Sir, this is essay. You cannot write university admission. You have to give me more detailed use case thought. University admission has multiple process. You can have blockchains. You cannot have blockchain. Uh, Can we? How's parallel computing help in what's BN? You are asking. Like, what's BN? Can we create more layers? Yes, L3, L4, L3, L2, L1. There are concepts. So you can create L3, L4, L5. There are multiple layer concept which is there, and till L3 it has been checked, and L4 somewhat tested, which is there. How parallel computing helps in blockchain networking? Uh, I don't know how your parallel computing would help in blockchain computing. I need to look at the use cases which would be there. Parallel computing. See, blockchain is not devised for parallel computing, etc. You can do, but it is a high performance computing. Blockchain is designed for data aspects, for its prevention of scaling or prevention of fault. So blockchain works on trust, traceability, transparency factors, not for higher computing. Blockchain, eventually, I mentioned previously, blockchain is facing its hard time on solving its own problem. It cannot run very high network nodes for parallel computing. That can be done decentralized. And why you need to keep that on blockchain? Uh, See, to be very fair with everyone, it's not everywhere blockchain can be used. Blockchain has its own set of limitations, and blockchain cannot be put in everywhere. Blockchain cannot be helpful everywhere. Somewhere it would be burden, somewhere it would be best tool to have, but it's varies from option to option. I don't know about layering. What you have written? Why to complicate? It's irrelevant. Computing, quantum computing, sir. First, let's solve the basic level of computing. General purpose blockchains are there. Then there would be general purpose for computing. Quantum computing can give you easier mining. Yes, mining periods would be there. High rewards would be there for you, but it will not change much. In only for few 0.001 bitcoins would be added to more. Peer-to-peer technology is discussed in PC. Peer-to-peer technology is a very old technology, and uh, it has been checked out on use cases also. There is a dark web which function on peer-to-peer technology, P2P computing, etc., which is there. I guess if there is no more questions, I could, I think I want to end up here. Uh, so thank you everyone for listening to me, and my LinkedIn is there. You can connect with me, and I can share help with regarding blockchain only. Uh, then you have Google and Chat GPT nowadays to answer your questions. Uh, any use case relevance question can be checked up